I don't know. Anyway, let's start. So I was saying that sometime back we spoke about using heavenly bodies for navigation. The moment we cannot see land, we are dependent upon sun, moon and stars to navigate and find our position at sea. So थोड़ा सा knowledge solar system का भी जानना जरूरी है. Being a navigator, we should know what all heavenly bodies are available to us, which we can observe, which we cannot observe, and the reason why we cannot observe. What are planets? What is sun? What is moon? What are stars? And if we are to take their angle, the azimuth, and the altitude, what all limitations do we have? Because every piece of equipment you use, it has advantage and it has limitations also. So we have to understand the knowledge in the subject fully before we start using the things. So solar system में कितने planets हैं? We all know 8 है 9 है?
Sir, 9 sir.
9. Any other answer?
सर प्लूटो को सर अभी कंसिडर करने लगे हैं अब तो.
प्लूटो को बीच में बोला नहीं होगा, फिर किसी ने बोला कंसिडर करते हैं. सो मे बी व्हाई? द रीजन is the planet moving, or is that heavenly body moving the way it is supposed to move when we define it with other planets, the parameters? Maybe it is behaving slightly differently, so maybe we cannot call it a planet of the solar system. Maybe it does not belong us. Because if it belongs to us, then it has to follow certain criteria. So I will just show you one figure from the book. If you look at this chart, these figures, just give it a quick glance. You can see the screen, all of you?
Yes sir.
Yeah.
Yes.
So on the first column, you have the name of the planets in the solar system, the sun, Mercury and other things. The mean distance from the sun. Why does it say mean distance and not the distance? Then there is a diameter, there is a period of rotation, and there is a period of revolution around the sun. We know the distances increase if the sun is in the center. Mercury is the first one, and then the distances increase. They are given in million miles into 10 to the power of 6. 36 million miles. Earth is 93 million miles. Then you see the diameter. Do you notice anything strange in the diameters of the planets?
No sir.
Anyone? There is no relationship, but if you see the first 4 planets are very small compared to the next 4 planets.
Yes sir.
Earth and Venus about same size, 8,000 miles diameter.
So why Venus rotation is not known?
Yeah, Venus rotation, that's a subject of astronomy. So still research probably going on when they're not able to figure out. So many things are still Probably scientists have not been able to find out a way why they have not been able to figure out the period of rotation. So I'm not too sure about that one. Why is it not been done? But the question is, they are not too sure what is the period of rotation. Sometimes they are steady, sometimes they're moving a bit slow. Sometimes you are always seeing the same side. Sometimes it's too bright to notice any change. So there are so many factors. Sometime back I read somewhere that there was a satellite which I think China or some country, they thought it is lost. They could not find the satellite. But after so many years, suddenly they saw the satellite moving against that backdrop of the planet. So in the background also, you know, so many things keep getting lost. You must have noticed even when you keep a lookout. If the sky is dark, sea is dark, and there is a mountain, huge mountain behind, like in the Mediterranean, sometimes it happens. Small boats and all, they get lost in the background, even small ships, you can't see them. So similarly, when you're observing planets and stars and these sort of things, sometimes you're not able to make out what is actually happening because the background is not clear. Venus being very bright in the sense it reflects a lot of light from the sun. So maybe they're not able to observe so many things. But there could be other reasons also. So if you look at the diameter, what I was talking, the 4 planets are much smaller, and suddenly from Mars to Jupiter you see the size 4,000 miles to 90,000 miles. So the inner group are 4 planets and the outer group 4 planets. Maybe Pluto again because it's very small size, so maybe not being considered. And see the speed at which they are rotating. If Mercury is taking 88 days to rotate, 88 days, and look at Jupiter, 9 hours, that means it's moving, turning very fast. And yeah, Jupiter is very fast. If you calculate, then you will know at how many kilometers per hour it is. Do you know at what rate the Earth is turning around the equator? By now you must have realized that the equator is rotating faster than the poles. Do you understand that point or no? Like a ball, if you balance a ball in your fingers, a football you must have done while playing football, the 2 fingers on top and bottom are hardly moving. But the center of the ball is moving because it has got a big distance to cover in those 24 hours as the Earth. So the equator will move much faster. The equator is moving at about 1750 kilometers per hour. You can calculate the circumference of the Earth, about 40,000 kilometers. You can calculate otherwise also 360 degrees into 60 miles into 1852 meters, divide by 24 hours, and you will get the answer. So if Earth equator is rotating at 1750 kilometers per hour, then you can imagine Jupiter, 90,000 diameter, see the circumference, and rotating in about 10 hours. So this is one difference to 4 small planets, 4 big planets. Period of rotation, all different, no relationship. And period of revolution around the sun. Definitely if the distance is more, it will take a longer time to complete the circle because more distance to cover. Here there is a relationship between the distance from the sun and the period of revolution, which we will study now. Kepler's laws. Kepler did a study about this one and he came upon a few laws. So a small brief over here. I will not go into this, but yeah, the inferior planets, the planets which are between the Earth and the Sun, Mercury and Venus are called inferior planets, and the planets beyond Earth, that is Mars, Jupiter, Saturn, they are called superior planets. Why I am mentioning this? Because the movement is slightly different. They are slight superior planets. So in this one, you can see that the one inside is the inferior, the one outside is the superior planet. How this moves and what happens, we will have a look after some time. So Kepler's law of motion. People have been very inquisitive. They have been studying all these sorts of things, and they have been coming up upon certain principles, because unless you study how the planets and these things move, you will not be able to get any meaningful information from them. So let me see if the slide is better. I have got some slides also here. So this is the way they are positioned. So in between Jupiter and Mars, you have some asteroids and meteors and things like that. Yeah. Now, one thing which also we need to understand, that the sun is a fixed object. You may look at the slide, but probably you can see my board also, or no? Can you see my board now or no?
Yes, sir.
You can see the board. And if you minimize the screen, you can see the board, and probably if you want, you can see the slide also. You can toggle between the two. Am I right? Can you do that or no?
No,
Yes,
sir.
sir.
इसको पिन अनपिन करते हैं तो हो जाता है.
we can do that.
Yes, sir.
Blur aa
That's what I'm saying. You can toggle between the two. If you want, you can look
we
at
can
the
toggle
board,
between.
you can look at the slide, correct? So let us say if there's a sun here, I'm drawing on the board now. And these are the paths of the various planets. So we have Mercury, the first one. We have Venus, the second one. We have Earth, the third one. Board is clear? Mars, red planet. Then we have Jupiter. Just to give you an idea. You will notice that I have not made the circles proper circle. You can see that, all of you?
Yes, sir.
The first thing is that the planets
Yes,
are
sir.
moving in an elliptical path. Elliptical path with the sun at one of the foci. If you see the slide, you will see F1 and F2, two foci have been made. Now, whatever you see on the board or on the slide is very magnified. Just to give you an idea. So the two or three things which I want to draw your attention to is that the path is not a circle, it is elliptical. For some planet, maybe like in the case of Mars, this is the point which is closer. That means this, if you see the elliptical path, the sun is maybe on the slightly on the right. For Venus also the sun is maybe on the slightly right. But for Mars or Earth, maybe the sun is, if you look at the path of the Earth, the sun is slightly to the left. For Mars, maybe the sun is slightly to the left. So the sun can be at any one foci, F1 or F2 of the elliptical path. That is one which Kepler discovered, that the path is not circular, they are all following elliptical path. So two or three relationship which he developed, which we will see now. The other thing which we spoke about, that the Mars and the Venus are inferior planets. You will notice over here that Venus Let us say, for example, if the Earth is fixed over here, Earth is not moving for, just imagine for some time. In celestial navigation, you have to do a lot of imagination. You have to use your mind, apply your mind. You have to think in 3 dimension. You have to behave little like out of body experience, you know. Don't think you are always on the earth inside your room or on the earth. You have to move out of your body, your thought process. Sometimes you have to place yourself outside the solar system. Sometimes you have to place yourself inside the center of the earth. Sometimes you have to place yourself on the surface of the earth. Sometimes you have to go out of the universe as if you are looking like God, you know, from the top of the universe, you are looking down at everything. So if you are able to use that kind of imagination, celestial sphere and celestial navigation becomes very easy for you because the dimension does not hold any relationship. You are absolutely free moving about in the space. So let's say the Earth is fixed over here. We stop Earth moving now for some time. Mars is moving like this. Venus is moving like this. That means you can always see these two planets in front of you moving. If you are here, observer, you can see these planets according to the diagram. But let us say there is a Mars and Jupiter. There will be some time that they will go behind you. You cannot see them. So the movement of planet for inferior and superior is slightly different, which we will discuss at some other point. You will also notice over here that Mars right now is in line. It is in conjunction. That means the Sun and the Mars are lying in the same direction. The Sun and Mars are lying in the same direction. Whatever GHA, LHA I have of the Sun, the same thing I will have of the Mars. This,
Sir, planets can never be in conjunction.
pardon?
Sir, two planets cannot be in conjunction with each other.
Yeah, they can be, why not? Everything is possible. This is, let us say Venus is here. So they are in conjunction now. I'll give you one very interesting example since you asked a question. I used to go for my evening walk every day. And by habit, you know, I'm an old navigator. I keep looking at the sky also when I walk. So I knew that, and I read in the newspapers also, sometimes in the newspapers also you have a section, the stars this month, you know, and they will give you a small description because newspaper has got information for every person. So I saw that I can see Venus as an evening star at that time. And I read in the paper that after 5 days, Venus and Mars will be in conjunction. So then I looked around Venus and I found a small red planet here. And I knew it was Mars because the newspaper also said that after 5 days, Venus and Mars will be in conjunction. Okay, which means if you look at the diagram that if Venus is like this, Mars would have been somewhere here. Mars would have been somewhere here. So still little distance to come. Then every day at the same time I used to go, I found that Venus is getting, Mars is getting closer to Venus. This gap was reducing. And on the 5th day, I found that they had become one. They had become one, very bright. So this way, they were in conjunction. They came right one behind the other, which means Mars would have come here somewhere. They are in conjunction. You understood now? Yes or no?
Yes.
So that way, like I said earlier, it's a very interesting subject and topic. If you take interest, you can. So this is conjunction when they are in the same bearing. You will see the inferior planet will be in conjunction twice, once here, once there. Maybe you can see, maybe you can't see, depending upon how close it is to the sun, maybe very bright or whatever. In this case, why I could see Venus, maybe it was like this. I think I should have put it like this. Maybe Mars was here earlier, then the Mars came here instead of there. Because in line direction of the sun, maybe you couldn't have seen. So maybe it was like this. But what is the main difference between the superior planet and the inferior planet in that case? The inferior planet is always in front of you. It will be in conjunction twice, superior conjunction, inferior conjunction, and it will be at the edge twice. It will be at the edge twice. Edge twice means what? This is called the angle of elongation. When it is in line with the sun and when it is having this angle. So this angle is called the angle of elongation. Angle of elongation, and this is 90 degrees. This is a right angle triangle. Why? Because this is a circle and the tangent to the circle is 90 degrees. Geometry. Anyone has any doubt on this?
Sir,
If
it's
there
an
is a
ellipse.
circle here, if there is a circle here, and I draw a tangent to the circle, this angle is 90 degrees. Any question? Yeah, tell me.
So this is an ellipse, no?
This is an ellipse, but it is such a huge ellipse. At any one point, it will always be a tangent, no? You draw a line and a tangent, and I told you initially that it is the elliptical path is also so small. I mean the ratio is so small that it doesn't really matter. So we can use it both ways. So this will be a 90 degree. Now this is pure geometry. If I know this angle of elongation, I can calculate the distance of the sun. If I know this radius, if I know how many days it is taking to make a revolution, so all these sort of calculations are possible by astronomers. So out of plain geometry, these people have been able to deduce so many things. We may come to this later. I think generally we do these calculations in phase one. So if you don't have now, don't break your head too much over it. The point which I'm trying to make here is all these things happen in the solar system. And when you look at your almanac, there also all the information is provided upon how planets behave and which planets you can see during which time of the year. When we come to the almanac, to our inferior and superior planets, superior planets can be in conjunction once. I will take the case of Mars. When Mars is here, it is in conjunction. But it will be in conjunction only once. But it can come in opposition. It can come in opposition. And it can also come in quadrature. That means 180 degrees. So the superior planet behaves slightly differently. It will be in front of you and it will be behind you also. But the inferior planet will always be in front of you. And the movement will be such, it will oscillate like a pendulum. Venus you can see like this, Venus you can see like this, and Venus you can see like this. So it will keep, the Venus will always be within this sector. Very interesting movement of Venus. We will see when it is a morning and evening star later. But Mars will be like this, and it will go behind you also. So this was just to give you an idea of the planets, how they move. Now, what is the plane of the solar system? What is the plane of the solar system? Imagine in the outer space, the sun is moving. And there is a particular level, a plane. Because you see in space, there is no sense of direction. Which is top, which is bottom, which is front, which is back, how you will explain? If you look at the Earth from outside the solar system, within the solar system, can you tell me whether which is top and which is bottom? Because the people are not falling the water or the earth, nothing is falling down. There is no top and bottom. It is a sphere, it is moving at a high speed. Now, when we say the earth is moving, rotating and revolving, at what level and in what direction it is moving? The point which I'm trying to make is, if I look at this as one level, one plane, this is the plane of the paper or whatever we call it. If I turn this through 90 degrees and I draw a line through the center of the sun, there will be a level which I will call 0. And if I draw another axis to perpendicular to it, that I will call vertical or 90 degrees. Let me say, if the solar system I draw like this, I hope you can see the lower part also. Let us say I draw a thin line as the solar system like this. Sun and all the planets moving. Try to imagine this is one plane. If this is one level and this becomes the other axis, which is 90 degrees to it. So if this is one level, the point which I'm trying to make is, how do we find the direction in space? How do we find the direction in space? Because I'm going to come to a very important point now. If this picture is already in your mind, then I would like to remove this and draw another picture. If I say this is the Earth and it is rotating west to east, and in the morning I had told you I had drawn this vertical line giving this north and the south pole. But actually the Earth is not vertical. It is inclined. It is inclined. Inclined to what? That is the question over here. Inclined to what? What is this red line that I've drawn over here? It is the plane of the solar system. So we say that the Earth is inclined 66.5 degrees. The axis of the Earth is inclined 66.5 degrees to the plane of the solar system. Or we say that this angle is 20, how much?
22 degree 23.6 minutes.
22.5 degrees? Yes or no?
Yes, sir.
What is the other? 22 and a half or 23 and a half?
23 and a half.
23 and a half.
23 and a half degrees, we say, inclined on its axis. Actually, it's 23 degrees, 26 or 27, some minutes, odd minutes. It's written somewhere in the book. So now you have to imagine that even though the Earth is rotating, it is not rotating upright. It is rotating slightly bent. Any of you have seen a globe? Do you have a globe at home? I had one, I couldn't find, otherwise I would have shown you. All of you have seen a globe
Yes, sir.
Yes, sir.
lying on the table?
Yes, sir.
How is the globe positioned? How does it look?
So slightly tilted.
Slightly tilted. The globe also is slightly tilted. The frame of the globe which you have, there is a frame of the globe, it is holding like this. There will be a frame over here holding the globe, and that also is marked in degrees, something like that. You will notice that is also tilted 23 and a half degrees. So this point is very important to note, which is the direction in space. 23 and a half degrees from what?
Sir,
Up
from the
is also
main
the same,
axis.
down is also the same. Yeah, up is also down, up is also same, down is also same. If I can look, when I look at the moon looks where? I have to look up to see the moon, no? Am I right?
Yes, sir.
I have to look up to see the moon. But
Yes, sir.
what about people who are on the moon? If they have to look at Earth, where do they see? They also look up, no? Because the part of the sky which is visible to you is always up. You cannot see below your feet, below the ground. You always look up. So if a person on the moon is looking up to see the Earth, and I am also looking up to see the moon, so which is down? I don't know which is up and which is down. So the direction, everything becomes relative. There is no north, south, east, west, if you look at it from that angle. So we have to give some reference point always. So the plane of the solar system where all the planets are moving around the sun, if we take it as a horizontal, and then if I take it as vertical, the Earth is rotating inclined to the axis. 23 and a half, the axis of the Earth is inclined 23 and a half degrees to the vertical. So coming back to the solar system and the Kepler's laws, keep this thought in mind. Let us move on. I will take you a little onto the slides now. Have a look back at the slide again. You can see the orbit of the Earth, elliptical orbit, with the sun at one of the foci, F1 or
Yes.
F2. You can see that one, no? Yeah. Now, the sun will be either at F1 or F2 for every planet. I told you in my earlier diagram on the board, the elliptical paths are also not equidistant to each other. For Earth, the elliptical path may be different. For Venus, it may be different. For Mars, it may be different. But there will be two foci, and the sun is at any one foci for that particular planet. If for Earth, if it is at F2, for Mars, maybe it is at F1. It doesn't matter. But what is an elliptical orbit? We will see that one. Let's do the Kepler's law first. Kepler's first law states that all planets revolve about the sun in elliptical orbits, with the sun situated at one of the foci of the ellipse. An ellipse is a locus of a point such that the sum of its distances from the two foci is always constant and equal to the length of the major axis. There would be some diagram over here. Okay, not here. You can see this one over here. Is the sun exactly in the center?
No, sir.
Sun is
No,
not in
sir.
the center. Not in the center, correct? Slightly off center. So what are these two foci? Let me show you another diagram. You see this one? You must have played this game sometime or in your physics laboratory sometime. How to find the locus? You put a pin at F1 or F2 and take two loops, and then if you put a pencil and make a circle, it becomes an ellipse. So two pieces of thread, and then you turn them around. A plus B will always be equal to C plus D. A plus B will always be equal to C plus D. Now somebody asked me that the path is elliptical. See what is written. The ellipticity of the Earth's orbit is only about 1/7,200. The line before that, though very correctly the orbits of the planets are elliptical, they are in fact nearly circular. So technology has enabled us to find that even there are small differences. That is why the behavior of the planets and all these things is slightly different. Why people realize this? Because they were behaving differently than they would have behaved if they would have been a perfect circle. So this is the type of slight variation that we have. Now look at this line. The orbits of the various planets except that of Pluto are also very nearly coplanar. That means all the planets are in the same plane around the sun. So if I look at the diagram which I drew on the board was as if I'm looking at the solar system from the top. But if I look at the solar system from the side, it means that all the planets are moving in one plane. They are nearly coplanar. Pluto is not coplanar. That means it may be going slightly up and slightly down. And also Pluto, the size is very small being so far away. So it is behaving slightly different than other planets. That is why astronomers probably thought that maybe it is not our planet and it belongs somewhere else. So you have any question on the first law? First law states that all planets revolve about the sun in elliptical orbits with sun at one of the foci. An ellipse is a locus of a point such that the sum of the distances from the point to the two foci of the ellipse is always constant, which means let me take you to the board once again.
Sir, why sun is at one foci?
Why?
Why sun is at a foci, sir?
Because the path is elliptical. No, this is basically pure science. You must have read in school also what is an ellipse. I'm not too sure.
Sir, path is elliptical, but sun position is at अगर F1 पे है
So that
तो
is why
F1
is
पे
the
ही
path
रहेगी ना?
elliptical? When does it become elliptical? We say, see, if the sun would have been exactly in the center, then the path would have been a circle.
नहीं सर, मेरे
Because
कहने का मतलब ये है
yeah,
कि जो सन जो है वो या तो F1 पे ही रहेगा या फिर F2 पे ही रहेगा.
yeah, that it will remain
तो
in one position. That's what I'm saying.
तो
That's what the definition is also saying. At one of the foci.
हाँ सर, तो फिर लेकिन जो इसका कैलकुलेशन है इस केपलर फर्स्ट लॉ का, ये है a plus b equal to c plus d.
Yeah. No, that
Considering
other point will become imaginary, no?
okay.
That will become imaginary. That is the science behind it. See, you asked a good question. Why is it not in the center? If it would have been in the center, the path would have been circular. Correct? Then we wouldn't have been talking about all these things. The path is elliptical. That's why this theory is coming into Now, how do they know that the path is elliptical? Because the Earth, they found that sometimes it is coming very near, sometimes it is going very far. Just look at the board. Can you see the board?
No, sir.
Yes, sir.
The astronomers found out that sometimes the Earth is coming close to the sun, sometimes it is going far from the sun. Yes? So then they said that if the path would have been circular and the sun would have been in the center, then the distance would have been the same all through the year. But during the course of the year, they found that sometimes she is coming close, sometimes she is going little far away. You have heard this before? That is why in that chart it says mean distance. Draw your attention to this word earlier, mean distance from the sun. Mean distance means the distance is not fixed. There is a distance which is closer and there is a distance which is far. So they have taken the mean and given it 93 million miles for the Earth. But actually it is less sometimes and it is more. So they found that the path is not circular, it is elliptical. And this is the theory of the ellipse. Here what happens, you know, look at the board. Look at the board.
Sir, Earth's path is not fixed because of its shape.
See, all planets move in elliptical path. All planets. That is the way the solar system and the universe is functioning. No path is circular. It does not depend upon the shape. There are so many other factors. Because see, we are not influenced by any one planet, gravity and so many other things, then that becomes astronomy and those sort of things. We cannot go too deep into that. But what we know is what we will discuss. The path is elliptical, and why we are discussing? Because it is affecting our navigation and it is affecting life on our planet and what we have to do in this subject. So that is why we are discussing this. Now, if you look at the diagram on the book or what I'm trying to draw on the board over here, the law says if I take any point over here and this plus this. In this case, I've drawn a little close. In the book, it is a little far. So this distance A plus B, and if I take another point here, C and D, A plus B will always remain as C plus D, equal to C plus D. Now, how is this made, this elliptical path? You asked me. See, in the lab, I don't know, as an experiment, what I don't remember now. What they used to do, they used to put two pins over here, two pin, and take one long thread, and they used to have the loops. It used to be looped over here so that the thread is free to move around. So take two drawing pin, put the pins through the loops of the thread over here, and then pull the string as far as it stretches. Put a pencil over there and then turn the pencil, keeping the string always tight. So you will find some place it will become long, this will become long, some place this will become long, and one path will be traced. So that is called the ellipse. Do you anyone remember reading about this or doing experiment anytime? No.
So, well, we don't remember, sir.
Don't remember. Yeah, maybe because the courses have changed over a period of time and what we studied in school was different. Sometimes science projects and if you are interested in doing little extra things. So you come across these sort of things even in school sometimes. So if you want to read more about this, you can read YouTube on so many things you have nowadays at your disposal. Try to figure out more for yourself. But in this topic, in this class, what I wanted to tell you was that all planets move in elliptical path around the sun. The paths are not circular. That is why we will come to the terms after some time, aphelion, perihelion, when the sun is far from the sun and the when the earth is far from the sun and when the earth is close from the sun. So one question is, does this cause seasons? When the earth is far from the sun, it is winter, earth is close to the sun, it is summer. Does it happen like that?
Yes, sir.
Yes, sir.
So that is not the right answer, gentlemen.
No, sir.
In fact,
because of the tilt
in fact, during July, the earth is far from the sun, and in December, the earth is close to the sun. So what causes seasons? Why I asked you this question? Because a lot of students tell me this one. There is a wrong notion concept people have. What causes seasons is the tilt of the axis, which I showed in the previous 23.5 degrees incline. That causes the seasons. So why we are discussing each thing? Because it is affecting our life and it will affect our navigation. That's why we discuss. So we'll come to seasons later on. In the meantime, we will take the Kepler's second law now. So Kepler's first law, gentlemen, these are all theory questions. Read the book, draw the diagram, try to understand. If you have any doubt, you can ask. So Kepler's first law. Another thing which Kepler noticed was the radius vector of a planet. What is a radius vector? A line joining the center of the sun to the center of the planet. Sweeps out equal areas in equal periods. Look at the diagram on the screen now. Go to the screen. Actually, I've got a slide and screen, everything. So look at the screen now on your book. Can you see that one? Figure 6.3.
Yes, sir.
Okay. You see everything is shown magnified so that you can understand. Otherwise, F1 and F2 is very close to each other. You will see that when the sun is far away from the earth or the earth is far from the sun is moving from A to B in a certain period of time. When the earth is in the opposite side, C and D, the earth is moving in a certain period of time. Can you tell me at which time the earth will move faster? During C and D or during A and B? The revolution of the earth around the sun.
CND, sir.
At which time it will appear to be faster? You see, it is moving at the same speed. Okay, but it will appear to be moving faster, the angular velocity during C and D, correct? Because it is closer, and when the body is far away, it will look as if moving very slowly, the angular velocity. You all have gone in a train. You have looked out of the
Yes, sir.
window. You have looked out of the window. Something which
Yes.
is very far away, very, very far away. When you are in the plains, very far away, one mountain or one tree, it will look as if it is in the same window you can see for a very long time. But something which is nearby, some buildings or town is moving very fast. Or let us take the example of moon in a car. When you're moving in a car or a train, you in a straight road you are going, the moon is there only even after half a minute or 2 minutes, 5 minutes. The moon is in the same position, no? But your land and other things are moving much faster. So the things which are far away, they appear to be moving slowly. Things which are close appear to be moving fast. The angular velocity is different. So what Kepler said? Kepler states that the radius vector of a planet sweeps out equal areas in equal periods. So if you take the same time, let us say 5 minutes or 1 hour, it may appear to move faster or slower, but the area that it is sweeping, it will be the same. So you can see the shaded portion in that figure 6.3. Even though the shape of the arc is different, the sector is different. One is thin and long, the other is broad and short. If you are able to calculate the area of the two sectors, the area will be the same. Is this point clear? So we come to the two definitions. Aphelion and perihelion. Helion is sun. In Greece, you know, Greek language, Helios is the sun. So that is why a planet is said to be in aphelion when its orbit is far from the sun. It is said to be in perihelion when in its orbit it is nearest to the sun. So in this figure, when is it in aphelion and when is it in perihelion? Around A and B it will be in
Aphelion.
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 So very easy to remember. Far, F-A-R, far. A aphelion. F-A-R, far. A comes in the center, A aphelion. And the other one, near, perihelion. N-E-A-R. So R is coming in perihelion, so near. So easy to remember also. Aphelion and perihelion. So down below again, if you see, at aphelion it is 94.45 million miles, perihelion 91.35. So they have taken the average and the mean distance to be 93 million mile, which you saw in the chart earlier. Any question about? Kepler's second law, gentlemen? I'll come to the third law. These three laws you must study today thoroughly as homework. Draw diagram, understand everything. Kepler's third law gives the relationship between the distance of a planet from the sun and the time it takes to complete revolution around the sun. According to this, planets which are closer to the sun have a greater angular orbital velocity than planets which are farther away. So just write down, there is a relationship which is not mentioned in this book, but I think another book it is there. T square upon d cube is equal to constant. I will write on the board also if you want to have a look. T square upon d cube is equal to constant. T is the time taken by the planet to make one revolution. D is the distance from the planet. Do this exercise for me as a homework. I will ask you tomorrow. D square upon d cube, do for Earth. See what answer you get. Do it for other 1 or 2 planets and see what answer you get. It will be a constant. Any questions, gentlemen? So we have come to the end of this session also. It's 11:15, 15-minute break before you start your next session. So I will leave you here with this thought in mind that the planets move as per the Kepler's law. Study the Kepler's 3 laws, make your diagram, do whatever. These are theory questions, they come in the exams quite frequently. And do this relationship for me, t square upon d cube is equal to constant. Find out what is that constant and tell me tomorrow if it is the same for 2 or 3 planets. Is it okay, gentlemen? Are we done for the day?
Yes, sir.
Yes, sir. Thank you.
Yes, sir.
Okay, then thank you so much. Have a
Thank
nice
you,
day.
sir.
I thank you for your patience and I hope you have understood everything I said. If not, you can tell me tomorrow. I can increase my pace also, I can reduce my pace also. So it depends how fast and how much you can absorb. I know the subject is a little not exactly difficult, but you may say it is irrelevant. So, but I still want to hold your interest because it is finally a very interesting topic. So thank you, gentlemen. Have a nice day. Enjoy the rest of your classes.
Thank you, sir.